Hi there, welcome to my channel mathssl. I'm speaking Saqib Latif. I'm going to show you now about more on quadrilateral, how to prove the quadrilateral in analytical geometry. First, I got in front of me a trapezium. Trapezium, if you want to prove, simply prove that one pair of opposite sides are a parallel. So, this is a trapezium. So if you want to prove the trapezium, then prove that one pair of opposite sides are parallel. Let me write down for you. Prove that prove that one pair of opposite sides are parallel. So I'm going to use the gradient formula to prove trapezium is uh, one pair of opposite sides are parallel. So this is a parallelogram. So first approach is both pairs of opposite sides are parallel, so we're going to use the gradient formula. Second approach is we can prove that diagonals are bisect each other, then we're going to use the midpoint formula. I'm going to show you now. So both pairs opposite sides are parallel, and then we're going to use, if you want to use this approach, then we're going to use gradient formula. Because gradient formula we can prove that both sides are parallel. And or second approach, you can do both diagonals bisect each other, and then we're going to use the midpoint formula. So remember, if you want to prove that both diagonals are bisect each other, then we have to use the midpoint formula. So I'm going to show you the diagonals now. Have a look here, this corner to that corner, and the second one is from this corner to that corner. So these are the diagonals. So this is the first diagonal, this is the second diagonal. So both diagonals bisect each other, which means they're cutting here. So if the midpoint of both diagonals are equal, then we can say the diagonals bisect each other. Then we can prove that this is a parallelogram. This is the short name parallelogram. So if you want to use the gradient formula, then we have to find the gradient of these two sides must be equal to each other, and then we have to find the gradient of these two sides, they also must be equal to each other. Or we can use the midpoint formula, midpoint between these 2 points and the midpoint between these 2 points, and both midpoints are equal, so which means the diagonals bisect each other. So that way also we can prove this is a parallelogram. I think so the second approach is better because easier to do. So anyone you can use. So this is a rectangle, and a rectangle is a parallelogram, also a parallelogram family. And to prove this is a rectangle, any one of the corner angle must be equal to 90 degree. Can be this angle, can be this corner angle, can be this one, can be this one. Look here, 90 degree. So need to prove the corner angle is equal to 90 degree. And also we're going to use the gradient formula. And or you can use equal diagonals bisect each other. On this case is the diagonals are equal and they bisect each other, so I prefer this, the first one. We're going to use always this one. So any one of the corner angle equal to 90 degree. So if you want to prove equal diagonals bisect each other, which means you're going to take diagonals from this one, this first diagonal, and from this vertex to this one is a second diagonal, and you need to use the distance formula. So if they are equal, then this is a rectangle. but we're gonna use this one. The corner angle we're gonna prove equal to 90 degree. Then we're gonna say this is a rectangle. I'll show you how to do this one. Must remember, if you need to prove the lines are parallel or the sides are parallel, so you're gonna use the gradient formula. For instance, this is ABCD, and AB are parallel to CD. So then we're gonna use the gradient formula. So we're gonna say MAB must be equal to MCD. Then we can say if the both gradient are equal, and then we can say sides are or both lines are parallel. And if you want to prove this one, AD parallel to BC, so then we're gonna say MAD it must be equal to MBC. So we need to prove the gradient of AD must be equal to the gradient of BC. Then we can say AD parallel to BC. And then this is going to be AB parallel to CD. Now, if you need to prove that this corner angle is 90 degree, then obviously I need to prove the adjacent sides. What is the adjacent side? Two sides that meet to create an angle called adjacent side have a common vertex. So this is the common vertex here, and the AB and the BC, these are the adjacent side. Look here, AB and the BC, they are the adjacent side, and this is the common vertex. Have a look here. So we're gonna say MAB multiply MBC must be equal to -1. This formula you're going to use a lot. So if you multiply these both gradient and answer come equal to -1, then we can say angle B is equal to 90 degree. So to prove that the angle is equal to 90 degree perpendicular, then take the gradient of two adjacent side and multiply. If the answer come equal to -1, then we can say the angle is equal to 90 degree. Otherwise not. Must be answer come equal to -1. So obviously the coordinates will be there, A and B and C, and then we can from there we can see if is equal to 90 degree or not. So if I want to prove this angle C is equal to 90 degree, then we take the gradient of DC and BC. So then if come equal multiply and answer come equal to -1, then we can say angle C is equal to 90 degree. So that's how we're gonna prove the rectangle. So you must remember, this is very important to prove rectangle. So first we need to prove this is a parallelogram, and then we can prove this is a rectangle. So first we have to prove that both diagonals are bisect each other, which means that's gonna be a parallelogram. And after that you need to prove this is a rectangle, and then you take the gradient of adjacent side. So AB and BC, for instance, these two adjacent sides, and you take the gradient and you multiply the gradients, and if equal to -1, then we can say the AB perpendicular to AB perpendicular to BC, then which means this is 90 degree. Sometimes they already give you that uh, this is a parallelogram, and then they say prove this is a rectangle, and then obviously in that case you only have to prove rectangle. To prove this is a rhombus, then we have to prove the diagonal bisect at 90 degree. So we're going to take the gradient of AC and the gradient of BD, and if they you multiply and the answer gonna be equal to -1, then we can say they bisect each other at 90 degree. Then we can say this is rhombus. Obviously also this is a parallelogram family, and so rhombus must be a parallelogram. So if they already give you this is a parallelogram and you have to prove this is a rhombus, then we're gonna apply this approach, the diagonal bisect at 90 degree. But if they didn't give you that this is a parallelogram, then first you need to prove this is a parallelogram. After that you can uh, prove that this is a rhombus. To prove this is a parallelogram, you have to take the midpoint of both diagonals, and if they are equal, the same midpoint for both diagonals, then we can say this is a parallelogram. So in this case gonna be the gradient of AC multiply the gradient of BD must be equal to -1. If the both gradient you multiply, the answer come equal to -1, then we can say they bisect at each other at 90 degree. Then we can say this is a rhombus.
This is a square, and first approach I would like to do, this is my favorite one, that the equal diagonals bisect each other at 90 degree. So the both diagonals, they are equal, QS and PR, and they bisect each other at 90 degree. Then on this way we can prove this is a square. So we need to take the length of PR. We're going to apply the distance formula is equal to the distance of QS. That's the first thing we need to do. And the second thing, we need to multiply. We take the gradient of PR, multiply the gradient of QS, and must be equal to -1. So which means we're going to prove that they bisect each other at 90 degree. So in that way, both of these requirements when meet, and then we can say this is a square. Now you must remember this is also parallelogram family. If they already indicate you this is a parallelogram and you have to prove a square, then in that way you're going to fulfill these two conditions. But if they didn't say to you that this is a parallelogram, so you need to prove this is a simple quadrilateral and you need to prove this is a square. So obviously first you need to prove this is a parallelogram, and then you can fulfill these two conditions. In that case you have to take the midpoints of both diagonals must be the same, then we can say this is a parallelogram. And if that is the case, then we have to add one more. Have a look. So we have to take the midpoint of PR and midpoint of QS must be equal, same, and then we can say this is a parallelogram. So have a look here. Midpoint of PR equal to midpoint of QS, then we can say this is a parallelogram. And after that, then you have to fulfill these two conditions as well. Then we can say this is a square. And there is a second approach also if you want to. A square is a rectangle of which the adjacent sides are equal. First prove that the quadrilateral is a rectangle and then prove one pair of adjacent sides equal. Right. So if they give you a parallelogram, like this is a parallelogram, you can see. So now, so we need to prove this is a square, so we can apply second approach. In that case we're gonna have to prove that any one of the corner angle must be equal to 90 degree. So if I want to prove angle Q is equal to 90 degree, so I'm gonna take these two adjacent sides. So I'm gonna take the gradient of PQ multiply the gradient of QR must be equal to -1, and then which mean the angle Q gonna be a perpendicular. Now second thing, then one pair of adjacent sides uh, are equal. So I need to prove. So whenever to do with equal length, to do with equal whenever need to do with equal length, then obviously we apply the distance formula. So we take the distance of PS and that must be equal to the distance of PQ. Then that's the second condition you need to fulfill. Then we can say this is a square. But if they give you simple quadrilateral and you need to prove this is a square, so obviously you have to prove also first that this is a parallelogram. So through midpoints you're going to prove this is a parallelogram. You take the midpoint of PR and must be equal to the midpoint of QS, and then we can say this is a parallelogram, and after that you have to fulfill these two conditions. So you can choose first approach or you can choose the second approach. So
Now this is the last one, the kite. In kite, two pair adjacent sides are equal and the one diagonal bisect other diagonal at 90 degree. To prove this is a kite, so this is not a parallelogram family. So you can prove one of these. You can prove two pair adjacent sides are equal. Then you're gonna use the distance formula, or you can prove one diagonal bisect other diagonals at 90 degree, which means longer diagonal bisect other diagonal shorter diagonal at 90 degree. So then which mean you're gonna use, if you need to prove that the diagonals are perpendicular, then you're gonna use the take the gradient of both diagonals and multiply. If is equal to -1, then we can say they are bisected at 90 degree. So in the first approach, if you want to use, then you're gonna say the distance. You're gonna say the distance CD must be equal to distance of BC, and the distance of AD must be equal to distance of AB, which means both pairs of adjacent sides are equal. And if you want to use this, I like the second approach, and then this means you're gonna find the gradient of AC multiply the gradient of BD must be equal to -1. And if they are equal to -1, you can say this is a kite. Please like and subscribe my channel, and if you have any question, comment below. I will assist you. Have a nice day.